Hi, and welcome to a presentation given by the Shadow Server Foundation. Open DNS Resolvers Report. A scan report on your network or constituency. Presentation aims and objectives. Introduce Open DNS Resolvers. Introduce Shadow Server scans and methodology. Highlight a sample Open DNS report. Describe key features of the report. Demonstrate how a national CERT can action an Open DNS report, and offer guidance on how to protect and secure Open DNS. Open DNS Resolvers, a summary. The domain name system, DNS, translates domain names to IP addresses so browsers can load internet resources. Each device connected to the internet has a unique IP address, which other machines use to find a device. An Open DNS Resolver is a DNS server that resolves recursive DNS lookups for anyone on the internet. With reference to the diagram on the bottom right of this slide, here we can see a simple lack of authentication can allow malicious actors to propagate DNS amplification attacks and flood victim sites with fake, spoofed DNS lookup requests, making them inaccessible. With reference to the diagram on the top right of this slide, here we have a visualization of Shadow Server's aggregated Open DNS Resolver device data, plotted globally by country, with the highest volume countries highlighted in red and the lowest in blue. It's reasonable here to state that the countries with the highest amount of Open Resolver devices directly correlates with the countries that have the highest amount of IPv4 infrastructure. Shadow Server internet-wide scanning. Shadow Server scans the entire IPv4 space for 70 different network protocols every day, and also performs IPv6 scans based on hit lists for selected protocols. These are primarily hello-type port application scans. Shadow Server does not exploit any vulnerability. Scans allow for identifying misconfigured, vulnerable, or abusable devices, unnecessarily exposed to attack surfaces, or simply just population enumeration scans. You can read more on why we scan at the URL on this slide. Shadow Server internet-wide scanning. Scanning Open DNS. This is a project to search for publicly available recursive DNS servers. The goal of this project is to identify DNS servers that will send a reply to any IP address for domains that the DNS server is not authoritative for, and report them back to the network owners for remediation. These servers have the potential to be used in DNS amplification attacks, and if at all possible, we would like to see these services made unavailable to attackers that would likely abuse these resources. Therefore, we are querying all computers with routable IPv4 addresses that are not firewalled from the internet on port 53 UDP with a specific request for the A record of dnsscan.shadowserver.org, capturing the response from the DNS server and passing out the result. For more wider reading and an overview of UDP DNS amplification attacks, please read the following URL on this slide, which will direct you to cisa.gov. The Open DNS Resolver Report. The report is available as a file in CSV format. The report file name contains scan_DNS. Reports can be sent to the consumer as an email attachment or downloaded via HTTP or obtained via a RESTful API. All report timestamps are given in UTC. Open DNS Resolvers Report, an example from our website. This slide presents a snapshot of a description of our Open DNS report that we publish on our site. We summarize here what the DNS Open Resolver report is, and we give a snapshot of the format of what the report looks like, and also a sample CSV file for consumer education. Please also find on this slide 2 more URLs for more details on our full Open Resolver report and also a DNS scanning server project, a Shadow Server. Actioning an Open DNS report. Looking at this slide, we have an example Open DNS report highlighting report fields such as the timestamp of the event, the IP in question, and the ASN. The next stage of action, for example, for a national cert to make use of such a report, is to perform a whois lookup as demonstrated on this slide, which highlights a Korean IP as the responsible network owner for the Open Resolver. This would allow the national cert to coordinate with the ISP for the IP to be remediated and the Open Resolver to be made secure. Verifying our scan results. The scan results may contain false positives if an actor attempts to spoof UDP replies to our scans. In some cases, when hosts have multiple interfaces, we may register a scan response from another interface with another IP, but report it out as the IP that we scanned for. If you would like to verify our results and to see if your server supports open recursion, try using the command dig plus short at your IP, dnsscan.shadowserver.org, from a computer that does not use the IP listed in the command as its authoritative DNS server. If the device does support open recursion, you should see the IP address of dnsscan.shadowserver.org returned as the result. Make sure your queries are not being filtered. Remember, the scan results we share are always for the previous day, with up to a 24-hour delay. Open DNS, protecting and securing it. Following measures on this slide can help to remediate Open DNS resolvers. Implement BCP 38, also known as network ingress filtering. Ingress filtering is the practice of monitoring, controlling, and restricting traffic entering the network, with the objective of ensuring that only legitimate traffic is allowed to enter and that unauthorized or malicious traffic is prevented from doing so. Take DNS queries from a trusted source to tighten service security. Implement source IP verification on the device in support of BCP 38. Implement response rate limiting, RRL settings on DNS servers. This is seen as a way to combat reflection attacks, where spoof packets are bounced off DNS services to attack a target, and hopefully rate limits can stop the high volume query streams. Disable recursion on authoritative name servers, and limit recursion only to authoritative clients. Thank you for listening to this presentation. Please consider subscribing to our reports. By doing so, you will join an ever-growing community of internet defenders dedicated to the pursuit of a safer, more secure internet.